Okay, welcome back. And for this week, I'm going to teach you how to import water and terrain data into our map. And these two both isn't perfect, and uh, so I'm only show you the principles how to get it done. Okay, let's go get started. So first, um, so we're going to import. When I say water, I mean those rivers and lake. So I'm not going to import oceans and sea. I only import those rivers data. So we are going to OSM data, overpass API again. We go to this API and we going to create a wizard, search on water. Will automatically create this for you. So it's basically a search for natural water. So this time I'm going to zoom a bit wide because originally in this scale there's no water at all. I just run it and check. You will see that this is lake, and there's another lake, and there's another lake. So the sea is not included, but everything else is included here. Okay. Uh, I already have a files that is already exported, so I'm just going to use this file for now. Okay, so paste here. So just like the other data like we just click on export and download as GeoJSON, or you can directly visit the API to download as an GeoJSON. It's going to be very simple. And if you don't know how to use it, go to help and you can go to the Overpass API document. It will show you how to use these things. But this API doesn't give you GeoJSON data, so you need to convert it by yourself. If you're using Python, you can use, I think you can use the OSM to GeoJSON and to convert this. And if you use npm, you can search OSM to GeoJSON like this. So you can convert it a OSM data to GeoJSON. Even I think this library gives you direct access to the GeoJSON API as well. So anyway, doesn't really matter. So we have now imported our water GeoJSON data, and now we are going to write up a, like we do here, load building. We need to write a load waters. Okay, and yes. So first of all, how do we uh, create a water in Three.js? You can just follow Three.js example. If you have knowledge in writing shaders or using any other game platform, gaming engines, you can write it for yourself. But for me, because I have no idea how to do water, so I just use this example. So you see here, Three.js gives us a very pretty amazing examples here for creating waters, and also this one as well. It looks pretty good, and we're going to use this one. Okay. Now you see here, it gives you a whole example of how to do it. So this water constructor coming from the water JS. So what we're going to do is I'm going to import it from here. Yes. So from three example JSM, and let me check. I think it's objects. Okay, this is examples. objects and the water. Right. Just to make sure I did this right, I just copy and paste again to make sure I did this right. Okay. Now, right. So to construct the water, we need three things. So we need a normal map for our water, and we need a water material, and we need of course, a geometries and mesh. So we're going to create two things for our in our global variables. So we'll have our net water and net water normal. So if you don't know what is normal is, it's kind of it's sort of a textures, but it's only to demonstrate the display the deeps data called the normal map. If you have ever used game engine, you will pretty familiar with it. Okay, and we also need a normal map, so we can find it thing here. So we go to the examples, and we can go to the texture. I think you'll find water normals here. And yes, so I'm just going to copy and paste again from my previous normal map, previous project here. I imported to your textures. The reason why I use the PNG is I compress it. So yes, and here I'm going to make a normal map here, and equal to 3.texture loader. So whatever the normal map or any other map is, they're all textures. Access textures and PNG and a callback function. You can just write functions here, not use this. Oh, this is ES6. If you use vanilla JS, you probably don't need this. And I'm going to copy the code they use over here. I'm not completely understand what you do, but I think you just flip around things. Okay. And now we need to create the config for our material. I'm just going to copy and paste from over here. Yes, I don't need this part. Yes, those are the things that we config we will need for create our water. I'm going to change this to 0.5 to 0.5 just to save some performance. Don't need that. And now, just like what we did over here, we need to load this water GeoJSON file. Okay, finish geo. Then when e success, JSON. And we need to get its data. The same as what we do like here. We need to read all the features we got. So the features. If you don't understand any of this, please watch my previous video. So we're going to loop every element in this GeoJSON as FEL. Just for making sure that these properties definitely exist, means all the information we contain here, like the name of the lake, name of the river, or how long it is, and what type of water it is. Okay. Properties. Natural is equal to water if it is a water items. So then we will create a water for it. Type must be polygon because some rivers might represent as a line string. So, well, I didn't write for lines. If it's a line, I didn't create anything for it. But if you want to, you can do it by yourself. So I'm going to create an add water function for this one. So I'm just going to import our coordinates and import our informations into this add water function. Okay, in the add water function, we're going to import the coordinates, of course, and the information. Just like what we did for our building, we're going to do exact the same thing. We're going to create a shape and use that shape to create geometry. So shape and geometry here, and we're going to loop everything as EL, right? And if I equal to 0, shape is equal to generate a shape, and this dot center. Otherwise, it will push a new polygon to our hole. Sorry, typo. Right. These processes I explained it in my building, how I build the buildings here, so I'm not going to explain it again. Again, if you don't understand any of this, please watch my previous videos, and those are exactly the same things as I built buildings in this product. So and I push every single hole into our shapes, holes, properties. Now we have created a shape here for our water. And now we need our geometry. So I'm just going to use the gem geometry for this one. Yes, that's it. The config will be curve segment 2, and for this time our dips will be very small, just 0.1. Again, we don't need this. Now, just like everything else we did, we rotate X and rotate Z 180 degree, and our water is new water geometry and this net water. This dot ir water dot add water. I haven't created this yet, so I'm just going to add a new group. Names ir water. Again, why I create a new group for this, because I need to update, like the line things, I need to update it. That's why I need to create a new group. Let's do it. Just do it here. Water is equal to 3 dot group. I'm going to add it to the sense. Water. Right. And the last thing I need to do is I'm going to change this color, because the water color from the example it got is pretty white, and I'm going to make it more blue. So, alright. Also, I think I missed something. I need to create a sound as well. Anyway, we can just ignore it for now. To change these colors. See, there's a save sense is not defined. Yes, here. Let's just say false. Don't need this. And the textures, because we already created. So for here, we're just going to write this .NET water normal here. Right. Right. I think I run it. Yes, I've run it. Alright. So I haven't coded low waters yet, so I'm just going to code it. So just right after every building is loaded, so that low waters. Now, right. If you go and see here, you see our water is already loaded to here, and everything's running a little bit slow for now. It's fine, but the water isn't moving, so there's no animation for the water yet. So we're going to write a update water at the end. We're going to add here right. So we're going to write a update waters to make this water animation. So it's very easy. So for I is 0 and I less than this .ir water children length. So it will loop up every items in IR water, which is all the waters we added in, and IR water children I for access this item, the material, the uniform, time, the value is, don't ask me why and why is this. You can go to the examples and copy the code exactly the same code as me. So I didn't dig into why it happens here. I just know you can do it. You can do it in this way. So now, alright, I didn't call the update water here. So we're going to call it update water over here, and let's do it again. Now see, something's moving, and the resolution isn't really great, but yeah, but it is moving, and because of sun direction, you might found a little bit weird. But I mean, if you know how to build shaders, how to build these sort of things, you can optimize it for sure. And I don't really wanna spend my times in this part. So yeah, I'm just going to skip the beautiful part. And okay, now that's the water. Because the water will actually slow down the performance. So basically, I'm just going to move, when I move to the next step, I'm just going to comment out this water section. Just don't want to waste any performance for this. And just let you know how to build these water things. And it's pretty easy. If you live in a city that with a lot of water, rivers and those canal things, you can use this data and this message to generate those things. Now, okay, let's go back to another part. It's terrain. Just like I showed you at the very beginning that I'm going to tell you how to build terrain. Is is a sort of data that uh, shot by the satellite. So see that in some satellites they carrying the laser, uh, like a laser camera that can detect the high data, the evolution data from for the ground. So basically, where we can download this data is from the space agency. So the most famous one is the NASA, is which we're using. So it's called Earth Data. Uh, it's an open data platform in NASA, and you can download data in this server. So let me show you how to download the data here, right? So you can just create a area, and you and search on VM, and you will pop up a range of data. Let me just reopen it again for you. Yeah. So when you open it, it will show you the map, and you go to wherever you want, uh, like here, and you select an area, and you search on DM data, and you can see this the new data. This is the old data. Just going to use this one, and you see here, and you click on here, and you will see the image. And if you click on download, but you need usernames and password to download the complete data. And I already downloaded, so I'm not going to show you here. And when you download this data, you can use this software called the QGIS. We're saying it needs some time to load up, and it's a QGIS is a software that dedicated uh, for visualize the geo data. So here you can open the OpenStreetMap like our data source, and I downloaded my data to here. I think is where's that where when I download it, maybe here somewhere. Right, right. This is not. Yes, all right. This HGT data. Sorry. So first is when you download it from NASA, the things you will download is HGT data, not the TIF data. This is the file that contains original data sets here. So you import it here. Like the things you will download is this big. This is a complete image. Just like I said last time, there's two ways of coordinate systems. One is been using OpenStreetMap is the Mercator systems, which is the code name is EPSG3A57. And but our this DM data isn't used this coordinate system. You use the WGS84 normal WGS84 is 4326 data. You can see in this coordinate system the whole map is being squeezed like this. So there's a slight difference from this coordinate system to this coordinate system. But you don't need to mine all this, because what we're going, the function we build, the relative GPS location function we build, will fix this by our center location, calculate our center location offset to the other locations. So basically what you need to do, well, this is an options, right? So you don't necessarily have to do this. You can select any kind of a way to export or to find this data. So for me, I'm just use this raster function. So you can go to the clip raster by extent and to select extents on canvas. So you can select a part of it and you can run and you generate this part. So basically, it's a tool that can let you cut image. If you go to select multiple, I think, and you will see that there's perfect match for our city, right? And let's go back to normal. And here you can export as geotiff, and you can export it to anywhere you want. That's the first option. The files we will need is this geotiff data. So, but I'm not using this method because it's a bit, can I say, it's a little bit too manual, and you need to cut an image every time. So I choose a more optimized solution, which is I can download the DM data from this website here, this open API here, and it's called Open Topographic Organization website. Anyway, so if you go to this website, you'll find how to do it. So in this website, they will accept a boundary box, which is like this. You can import the boundary box like this. So you will need the east, north, south, and west coordinate. It's not like the 4 points of it's not the 4 point of the triangle. Not triangle, sorry, rectangle. It's the 4 points of the middle points of the edges. So basically, I know this is a little bit complicated, and what I did is I write a function to calculate a boundary box. If you're using this method, you can write it by yourself. I only tell you the principle, how it is, how it works, and for this method in my own project, I did this. So basically, I import the center and the distance. So I use GeoLab to calculate, to export, to return the east, west, north, and south points by the center location and the distance. So the east is 90 degree, north is 0 degree, and the west is 260 degrees, and south is 180 degrees. So I will calculate this boundary box. I import this boundary box into this API, to request this API, and you will download the TIFF files for me. You don't need to write this in Python, and I think you can find very similar things in any other language. For example, Node.js. I think it's actually easier than use Python, but I have another purpose, so I just use Python instead. Okay, now the master data is the first. It's one option, and when you cut an image from QGIS, you need to notice that this center point is a little bit different than the then the center point you set up. For example, I set up center point like this, but my current center point is like this. So you need to calculate an offset. Well, this will happen if you manually cut an image from the whole image. So you don't know where is the center point. You can't set up a center point. At least I don't know how to set it up in this software, but maybe you know. Now, if you did what I did, then you will have different center point issue. Now, what my solution is that I can show you just a glimpse of how I dealing with these issues. So basically, I will import this 2 point, which is we'll list it here. So it will give you the left button coordinate and the right top coordinate. So you will going to use these two coordinate to get the center position from the GeoLab. There is a get center method. You will get the middle point, and you use this middle point to calculate the offset from here to here. Then you can move the whole plant or transform the whole plant from here to here. So just move a little bit, and then you will match your map. Just tell the principle how it works and why it works, and I'm not going to show the code for this part because it's getting really complex, and it really depends on how you collecting the data, how you did this. Except from NASA, if you go into almost every space agency, for example, this is the Chinese space agency, they will all have this sort of like open data access, and they all have this sort of open GIS systems like this. So you can download any of these images, and I think you can get the DM image as well. I haven't figured out how, but you can. Or you can, this is the ESA website, and I haven't figured out how to download DM data, but I'm sure it's somewhere. Yes, and yeah, let me just close all this, right? Now, I'm going to use the GeoTIFF data I downloaded from that API, which is a perfect a square that that by my center location. So I'm just going to import it to here. You can see my center location is here, and it's a perfect square, right? That's it. So I just copy it here, and let's go to here, right? Okay, now I'm going to write a new function called load terrain. Let me check on my previous project because I might forgot. I need to give you the definite right information. All right, cool. Except from now we have a TIFF geo data over here. Well, I can't see it inside the VS Code. We need a library to read the this TIFF image. So we're going to use GeoTIFF from npm. You can download it from npm. So I'm just going to install it here. I'm going to import it now. Import as I think it's GeoTIFF from GeoTIFF, right? That will give us access to read the information contained in the TIFF file. And we're going to copy our bounded box because we're going to need it. Well, if you calculate from your front-end JavaScript and you will pass this to your backend API, so you will definitely have one. But for me, I just copy and paste to over here. Okay, this is my bounded box, and now I need to write. All right, because the GeoTIFF requires to use the assign function, which is the background story is that in JavaScript the code by not actually running in this set order, so sometimes it run this before this. Well, it's not possible. Sorry, some points runs the second one before the I is equal to 0. Well, it really depends on the engine itself. So for solving some problem caused by this, we have to use assign. So the code will wait until this functions finish running and to move on. Right, now we import our TIFF to relative and is await relative get image. So it will read this TIFF and save it to our variables here. Now we need a star location. Let's say is box. So the first one will be the longitude and B box. Let me check the first one is longitude. Yes, the first one is longitude. It solves that latitude. Right, basically this is the 2 points, the left buttons and right top points here. Okay, and now we have the start point and end point. Now we need to calculate we need to convert the GPS location to the XY location in our own map. So we're just going to import star center. So we calculate this now, and we calculate the right top, this GPS relative location center. Just use the method we wrote on my last, no, it's actually last video. Now we need the X, it's the width and height of the terrain image. It's absolute, so there's no minus, negative, no negative, and minus right top 0. The 0 is X, so we use this X minus this X, then is distance. And Y is not actually, I can write up Y is equal to X because it's a perfect square. But if it's not, then calculate the height. So bottom 0. Wait, so it's 1. And right top 1. So we now use this Y and this Y, so we get the the height of the image here. So geometry, so we create a new geometry that this time we're going to use plan geometry, not the plan buffer geometry. Now we need import width is x and height is y. The width segment is x minus y, and the height segment is y minus 1. Sorry, x minus 1 and y minus 1. Now it's the data. Now we need to officially read the data from our TIFF image file. Read rasters. This is master floor. So this allowed this methods to resample the image, so which means to adjust the size of the image, but this only accepts int numbers, so it have to be a whole number. So we use master.flow, and remember you have to use master.flow for some reasons. You can't use like the paste int or anything else. Okay, the sample method is don't have to change this. You can just use the default one, which is you just leave it blank. And interlevel is 2. Now, if you don't know what is this, just go to read GeoTIFF libraries document. And now we can read through all the data. What we're going to do is so the geometry is a point cloud basically. It's an array of points, and our data is also an array of points. So basically, we're going to read through all the geometries point and to adjust the high values by this data. So if geometry dot verticals I geometry dot verticals I z. In here we use z instead of using y. Is for a reason. Well, I think I tried to use y before, it doesn't work, but you can try to use y. And because of this, numbers from the data will be huge, so we just make it looks better. So we just make it smaller by this divided by this number, but you don't necessarily need to do this. Geometry dot verticals needs update is 2. I think actually, you don't actually need to write this, I think, but I just leave it here. Geometry that rotate. So, like everything else we did, we need to rotate the x, and geometry that rotate y. For this one, you need to rotate y as well, because the my GeoJSON data is different than the TIFF status directions. So just need to add one of this. Well, it really depends. You can run it out and see what you need to do. Right. Then we have a geometry now, so we can just create a plan that is new 3.mesh and import geometry. Now we need a material. We just set a temporary material for this one. I just use the colors. I think this one is the yellow color. And the side, you need to set, this is a plant, you need to set it double side. And we're going to use wireframe to generate this data. And this graph is plant. We're just going to save it to our global variables. Okay. a little bit lost. And just for make looks better, just set the position dot y is equal to -3 and this dot since dot add. Yeah. Oh yeah, I didn't call the uh, loading function yet. So let terrain. Now it takes a bit longer to render the terrain data now. Right, sorry, I found that I wrote it wrong here. It should have been placed in the for loop. Cause a very heavy workload for a computer. So yes, yes, this should work. So here we have successfully imported the terrain data here, and if you can see that from the Google map is definitely a match from what we where we exported. So this is the building here. So you'll see these three buildings. So we go and see here these three buildings, right? So and we go to this mountain. We see three peak here, and like this, and you can see the exactly things like this. So the reason why this mountains looks a bit, a bit taller than what it looks from the Google Map first. Well, you can't fully just Google Map yet. And second is that it's about these numbers here because the z value isn't really fit the coordinate system in Three.js. So yeah, basically it's because of that. And I guarantee you the mountain definitely looks higher, taller than the one looks in Google Map. Anyway, so yes, this is how we did it. So and you see that we have imported our terrain here, but our building isn't really go with the line with the terrain. Like for example, this one, this is the Edinburgh Castle. It should be uh, on the hill, on this hill, but it's not. So I'm not going to tell you how to do this in this video because it's I don't the technology isn't mature yet, but I can show you how I did it uh, uh, and what and the principle behind it. So basically, there's multiple ways to calculate that sort of things, and I haven't figured out the best method to do it, but this is the way. So for each of the building, so first we will save our terrain data. So I already saved it to the ground, I think. Yes, the ground. So we need to access this data. And you see how slow it is because you need to calculate a lot of things by this. So when we have each of the building, it will take one coordinate from the building. So it could be the any one of it, maybe the first one, maybe the last one. So you will start to calculate. So for example, this one, so you calculate the nearest, so it will start to calculate the nearest uh, coordinate in the geometries, geometric point cloud. So for example, for this, I think define this point as the nearest point. So it used this y value as this y value. This is how they get it done. But this is not, never can be perfect because it's automatically generated. And because we don't have the real buildings, the height data, so it's not going to work. So I just wrote this algorithm to calculate it. So first I wrote this shortest method. So it will return the shortest point of the geometry point cloud, and you will take the y values as this building's y values. So that's very simple. And yeah, this is today's video. Well, you can apply the same principle to the row as well. You see how my row is now have this altitude data, right? And this is the last videos I think. Except this one, the other technology, I'm still exploring the other way to qualify this one to make it more realistic and beautiful. But yeah, so probably if there's any chance that I want to share all of that, I will make the new videos again. But for this series, this is the end of all. Thank you.